Hi, welcome to PiPad Mathematics. I'm Professor Lamb, and this is another video just to kind of show how you can use the iPad to teach mathematics. This is going to show a problem that's pretty popular, if you will, in the problem-solving arena. George Lynchner is one that I've done it. So anyway, I posed this problem. I like to kind of pose it with using Minecraft. So here we are, we're Minecraft, and we have now made a white cube. So here's a white cube that's made in Minecraft. And the question is, what happens if we were to paint that cube red? Alright, so now we have our white cube and our white block, and we've now painted it red. So our question is, what happens after we've painted the white cube? So it's a white block, everything's white, it's all big and white. And then we get some paint and we paint the outside of it. And we're going to now, in Minecraft, we're going to crush it. So we broke it up into all these tiny pieces. The question that you pose students is, when I have my red cube and then I break it into the smaller pieces, how many of those smaller pieces have red paint on them? And so the questions come from students, you talk about it, you say, well, what do you mean smaller pieces? Well, each of the smaller pieces is going to be 1 centimeter cubes. So you got your original cube, big cube here, Minecraft cube, and you broke it up, crushed it, and now it made small 1 centimeter cubes. How many of those 1 centimeter cubes have red paint on it? Remember, the original block was white, and then you painted it red, and you broke it up. Now, how many of the smaller pieces have red? And so the smaller pieces are 1 centimeter cubes, and each cube has 6 faces. So how many of those? One way you could do it is, how many of those faces have red paint on them? So we have our original Minecraft cube, Minecraft. We have our original Minecraft cube, and after we break it up into, I don't know how many pieces, they're 1 centimeter blocks. How many have 0 faces painted? How many have 1 face painted, 2 faces painted, 3, 4, 5, and 6? And you pose that question. Then students are going to be like, well, you want students to get to a point where they say, oh, I need to know how big the original Minecraft block was. I need to know how big is this Minecraft block. Great question. And that starts the discussion. That grabs their attention and engages them in the problem. And from there, you can say, well, what if we have this cube? Okay? What if we have a 3 centimeter, so we have 1, 2, 3 centimeter by 3 centimeter cube. And this app is called BlockArt HD. And so we have this, and we'll start with a smaller problem. If I have a 3 centimeter cube and I paint the outside of it red, so here's my paintbrush. Let me go back. Paintbrush, and then go back here, and I paint it red, and I paint this one red, and I paint this one red, and so forth and so on. I paint the whole outside red. How many blocks have how many, after we've broken it, Minecraft hammer smashed it into pieces, how many of those pieces only have 1 face that's red? And when we undo, we can use this block to say that one. Oh, it's only going to have 1 face painted red. Because if you can tell from this app, that one side or that piece right there, that's the only face of that smaller 1 centimeter cube that's painted red. and then we go to this side of our original, and that one's going to be painted red. So that block only has one side painted red. And then this one only has one face painted red. This has one face painted red, and this one has one face painted red, and this is one face painted red. So the question is, how many of these that are painted on the outside, when you break it up, only have one face painted red? And the answer is 6. So let me go here. Bear with me. There we go. So what we have is, when we have a 3 centimeter cube, how many have one face painted? The answer is 6. Okay? Now the question is, how many have two faces painted? Okay, two faces painted red. Well, what I'm going to do first, this one has two faces painted red. And then notice this side right here. It's got one there, one there. So this block is going to have two faces painted red. And so this 1 centimeter cube is going to have two faces painted red. And this one's going to have two faces painted red. And this one's going to have two faces painted red. And this one's going to have two faces painted red. And this one right in here is going to have two faces painted red. And this one has two faces painted red. And that one has two faces painted red. Two faces, two faces, two faces. So now what we have is, we look like a wrapped up present for Christmas. So we have to count how many. Well, on this side we had 1, 2, 3, 4, and then we count this opposite side, 1, 2, 3, 4, and then we're going to count these down the middle, 1, 2, and then 3, 4. Now I'm looking at it, I see it in my visual spatial kind of skills, if you will, but you need to see it. Our students need to see it. So they need to put their hands on it. So you hand them an iPad, or you hand them some just connecting cubes or blocks, and you want them to touch it and feel it and see that these are the ones that have two that are counted off. Now, another way that you can do it is, you can actually say, that one is gone, that one's gone, that's gone, that's gone, that's gone, that's gone, that one, that one, that one, and that one, and that one. And so this one. And so you look at it, and all those have the two sides painted. And how many were there? There were 12 of them. So we record that on our iPad, explain everything app, and we had 12. Okay? How many had 3 sides? So we go back to our cube and we say, how many had 3 sides? So I'm going to get my paintbrush again, and I'm going to say, that one has 3 sides. That one has 3 sides. And you can see those 3 sides. It's going to be this one, it's going to be that one, and that one. It's going to be these 3 outside pieces. So that one is painted red. That one's painted red. That one's painted red. That one, that one, that one's painted red. And if you remember, I'm going to go ahead. This one had one face painted. This one had one face. This one had one face. This one had one. This one had one. This one had one. And so now it's only these that are in the corners, that are the vertex blocks, if you will, of our original cube. And so how many are they? There are 8 of them. So we go back and we record that. We get 8 here. And now our final question is, how many have 0? How many have 0? Well, we crush that one, crush that one, crush that one, crush, 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 because we already counted it, and we're left with that one in the middle, that one dead center, the one right in the middle of the blocks. So we record that, and we end up with, how many have 0? 1. Now, no blocks had 4. No blocks had 5. No blocks had 6. Now, mathematically speaking, you can figure that out. The math teacher knows, hey, And we're not going to need 4, 5, and 6. The only time we'd need 6 is if the original size cube was a 1 centimeter cube. Then you'd need the 6th one. Well, you don't need to worry about that. You can have them record it, and then after a couple of trials, they realize we don't need these over here. We only need to worry about the 3-sided, the 2-sided, the 1-sided, and the 0-sided. Then we pose the question, what happens if we have a 4 centimeter? Our original was a 4 centimeter cube. Well, we can go back to our app and we can build a 4 centimeter cube. We can build a 4 centimeter cube. And then we can go and we can record the answers. This is so much fun. Now we have our 4 by 4 by 4, right? Okay. And then I'm going to need to paint that one because that's just not right, being the white one out there. So here we go. We have our 4 by 4 by 4, and so how many are going to have 1? So we count how many are going to have 1. We can zoom in a little bit and we can see it's these 4 that are right there in the center of the block. So what I can do is I can say, all right, well, it's this one, 2, 3, 4. Those only have 1. 5, 6, 7, 8. Those have 1. 9, 10, 11, 12. 13, 14, 15, 16. 17, 18, 19, 20. 21, 22, 23, 24, and that should do it. And so you can see kind of which ones only had one side painted red. And so we ended up with, there are 6 faces, and we had 4 on each face, so 6 times 4 gives you 24. And if you notice, I'm kind of using language that you want to get to. So we had 24 there. Okay? And now we end up with how many have 2 sides? Well, that's going to be these in the middle, or these on the sides. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So now we have 24. Okay? There are how many edges? Well, we had 1 edge, 2 edge, 3 edge, 4 edge. So we have 4 edges, 5, 6, 7, 8, 9, 10, 11, 12. So did we count that right? So we had 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yep, 24. Okay, so we have now 24 that have 2-sided. Okay, and how many 3-sided? We had 8. Okay, and then how many had 0? So that's what's left in the middle. This cube that's left in the middle, after we take these away, that's how many are not going to be painted. Okay, these would all be white. So we can get our paint, and these would all be white. Okay, and so it would be a 2 by 2 by 2. 2 times 2 is 4, times 2 more is 8, and we are getting in here, and it's 8. Okay, now what are we trying to do? We have them answer these questions. We have them figure it out. Now we look for patterns. Okay, we look for patterns, and how do we explain that pattern? Well, the one on the face, the one on the idea of how many are in the face. I'm going to undo all that. So one-sided, you look at, it's going to end up with that square in the middle. Okay, it's going to end up with that square dead center in the middle, and you have to ask yourself, well, how do I represent that square? How can I mathematically represent that square? And so I can add another page, and if this is my original, okay, this is my original, and what I'm ending up doing is these on the edge, these corner ones are going to have 3. These 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 will have 2, 2, 2, and 2. And these in the middle will have 1. Okay? So if my original, take this, if my original length was 3, then what we did is we took this side off, and we took this side off, and we were left with just 1 in the middle, so that gave us just 1 cube in the middle that had one side painted red, and we had 6 faces, so 6 times 1 gave us 6, and that was this original right here. Now the question is, what happens when this became 4 down here? What happens when this became 4? Okay, then we took 1 off the end and 1 off, so we took 2 away. So we had our original side 4, we subtracted 2, okay, and then it was that squared, because it was going to be this side times this side, and that side length is going to be 4 minus 2. That was 4 minus 2 is 2. 2 squared is going to be 4. How many faces? 6 faces, so that gave us times 6. Then if it were 5, it would be 5 minus 2 squared times 6. If it was 6, it would be 6 minus 2 squared times 6. If it was m, it would be m minus 2 squared times 6. So you got m minus 2 squared, and then multiply it times 6. Alright, so we have this two-sided. We had m is 4, okay? M was 4, minus 2 is 2, square it, gives you 4 again, multiply times 6 gives you 24. If it was a 5 centimeter, then I'd go 5 minus 2 is 3, 3 squared is 9, 9 times 6 is 54. If I had m centimeters long, then I'd go m minus 2 squared times 6. That's algebraic. Depending on the age that you're working with, younger kids, you just want them to find out how many blocks have certain number in a finite space. Then you get into the infinite space, and the unknown, the m, is going to be how you create a rule. So it's m minus 2 squared times 6. The number on the sides, or the side length, that's what this is, the two-sided. If we go back and we look at here, the number inside of that block right there, we had m length, then we subtracted 2 off of it, okay, so we had m length, we subtracted 2, and then there are 12 edges, so we multiply by 12. Does that work out? Well, we had m minus 2, and then we multiply that times 12. Well, m minus 2, m is 3, 3 minus 2 is 1, times 12 is 12. 4 minus 2 is 2, times 12 is 24. With a 5, it's going to be 5 minus 2, which is 3, times 12, it's going to be 36. Then the next one's going to be 6 minus, and then n minus. And then the last one, with 3 sides, it's always the number on the vertex. There are 8 on the vertices. The last one is going to be 0. After you take you take away a dimension of 2, that center one. So what happens is you had a 3 centimeter cube. You took away the dimensions. You took m minus 2, the dimensions, and then you cubed it. So the dimension minus 2, because you're taking off the sides, leaves you with 1. 1 cubed, 1 cubed. If you take off 4, 4 minus 2 is 2, 2 cubed is 8. 5 minus 2 is 3, 3 cubed is going to be 27. And then, so m minus 2 cubed is the rule for 0 sides. M minus 2 squared times 6 is the rule for one side. M minus 2 times 12 is going to be for two-sided. So this is how you can work the problem. You can start off with Minecraft. You can use the HD, Block HD or BlockArt HD. You can write on it, use and explain everything. You can go back to just working on the board and having the students work on the problem, paper and pencil. Pose a question to them. That's kind of what George Lynchner says. Just pose a question, have them answer it. Pose another question, have them answer that. Pose another question, have them answer that. That's the idea. We pose questions. This is me talking how you solve it, talking how you as a teacher can teach it. The idea is that we want to get students to think. And we want to get them to think about this old mathematics using new technology. So thanks for watching. It's PiPad Mathematics.